Hi to my esteemed viewer. Those of you who are tuning in to this channel for the first time, welcome. Today I would like us to make a continuation of our recording on preparation of material schedule, and today it's a schedule of a structural concrete. The structural concrete we are interested in doing today is for the bases, strip footing, and also the ground floor slab. On the side, you have a presentation of a simple plan, foundation layout plan, which we are going to use to get our material schedule. But before we get to that point, these items, that is from the bills of quantities and to the material schedule, they normally go hand in hand. And the one that normally comes first is the bills of quantities. So that means before even you get to the bills of quantities, then you need to get the information from somewhere. In most cases, as a quantity surveyor doing an estimation, this information you get them from a specification, that is to the structural drawing. If that one is not available, then of course you'll proceed to what we call the assumptions. So before you get there, you normally check if the drawings are available. And if these drawings have been given, then there is a specific point that you need to look into. And that specific point that you need to get into is normally on the side. It can be on the side of the structural drawing or at the bottom bar, okay? But then it's always indicated notes. So those notes is where from the notes is where we are going to get our specifications. Of much interest to us today is the specification regarding the structural concrete we are going to deal with to get its schedule of materials. Looking straight into that, on the side, note number 2 is talking about concrete 2, British standard 8501 as follows, unless noted otherwise. What that means is that what you're having here, let's look at it. All these are the concrete information that we are going to rely on in doing our estimation. Then we'll prepare the bills of quantities just for that concrete on the specific items we've mentioned. After that, then we get the schedule of materials for those quantities that we shall have come up with. The interpretation of this, which is of much concern or interest to us today, will be as follows. Where the arrow is pointing, it's stating grade C20 stroke 25, cylinder crushing strength of 20 Newton per square millimeters, and then cube crushing strength of 25 Newton per square millimeters. The structural engineers will explain to you this better. In my own understanding and interpretation, C20 means class 20 of concrete, okay? So the C20 means this is now concrete class 20, okay? So concrete class 20, it's a specific class of concrete, and that is what we are going to measure on today, okay? While that is now information 1 that we need to take note of. The next information that is also quite crucial for you is the 25, okay? The C20 means class 20. Then stroke 25, what that means is that the minimum aggregate, that is now talking about ballast, it should be of a minimum diameter of 25 millimeters, okay? So the 25 minimum diameter of the minimum diameter of the aggregate, this is the coarse aggregate, is 25 millimeters, okay? So those are two crucial information which we are going to lift from this particular information. We are going to apply that in our preparation of the bills of quantities. And the reason why this specific information, that is the specifications, are crucial is because they normally determine how much we are going to price for these particular items in the bills of quantities. So they are very crucial, and you should never at any point ignore this information, okay? Because even if you're preparing the document for yourself or the client, or you are preparing this document for contractual purposes, these specifications are very crucial. Worth noting, C20 is class 20, then stroke 25, that means minimum diameter of the aggregate, or rather maximum diameter, sorry, this should be maximum. Okay, let's just, maximum diameter of the aggregate is 25 millimeters. Okay, so once that is noted, then we'll get back to our plan. Okay, of course we've understood the interpretation. Now we are going to the plan to draw the quantities of these specific items which we are concerned with today. Okay, so this is our let me call it blank Excel sheet, where we're going to draw just a simple quantities for those specific items we have talked about. Okay, so as usual, just note this is ID, which is basically for identification purposes, and then I will have our description here. I will have our description at that point. Then after our description, then I will have as usual, I will have our unit. Then our unit, I will get our quantity, then I will get our rate. I'll get our rate here. Okay, then after the rate, I will get our amount. Okay, but today our concern is a little different. We are not going to focus on detailed bills of quantities. For all those who need the steps for the preparing of detailed bills of quantities, please, I will attach to this video all the links that I have made for the videos explaining to you the steps of how to prepare the bills of quantities. So today that is not our major concern. So once you have this type of layout, then we are going to introduce another column where we are going to have the materials. Okay, actually let's just first separate it, the bills of quantities first, and then after that, on a different specification, we are going to have the part where we are going to explain now the schedule of materials which we've talked about. So in this case, the first of the items is to give a general description of the items that we are dealing with. So we'll talk about vibrated reinforced concrete, class 20 stroke 25. Okay, yes, so vibrated reinforced concrete, that is a part of the description of the concrete, which means the vibration which you do to the wet concrete, just to make sure that you are getting the maximum strength as per the design or as per the specification. Of course, class 20 is part of what we are dealing with in terms of the specification of the class that we've been given. Okay, so this being the description, we leave it there. And then the next is to get the quantities of those specific items. So let me just work out this one. So the specific items we are dealing with now is number one. Number one, we are dealing with this should be 01. So it's vibrated reinforced concrete class 20 in. Okay, so once we have that, so first one, we are going to talk about strip footing. So the strip footing concrete here is measured in cubic meters. Okay, so it's worth indicating cubic meters. You will see how important those units are going to help us when you are ultimately getting the material schedule. Then we are going to calculate very quickly the quantities of the strip footing. So of course, strip footing, as you note here, it's coming from let me just draw so that you see. So the strip footing comes from this point up to that point, and then there is that bit up to this bit. all the way that way. Okay, so those are the strip footing. The parts that are in between the column bases are what we refer to as the strip footing. If at all there are no bases, then of course we have straight away what we call a strip footing as a whole. So in this case, according to our interpretation, according to what we have here, then let me just erase this bit so that it's more clear to you, to be able to read it well. So what we have here, at the upper part, we have 3200. 3200 has been given from the centers. 3200 has been given from the centers of the walls, or rather you can say the columns. But then now we need to take away. You can see there's 1000 here, and then there's 1000 this side. Okay, so from these 1000s on either sides, we need to. So half of it is basically 500. So the 3200 comes from the centers. Okay, so we take 3200. Okay, so basically what we are looking for is to get the length first, the entire length, and then you multiply by the width, okay, times the depth of the concrete. That is how to go about it. So our first approach is to get the length. So in this case, it's going to be 3.2. Then we subtract, this is 1000, divided by 2 gives you 500. So basically there we have like 0.5 times 2, okay? That is the length on a long grid A from 1 to 2, okay? So in this case, we should basically multiply this by 2, okay? Because what we have on the top at grid A is the same as what we have on grid B, okay? Then we're gonna go to grade 1 and grade 2, okay? So that means I will just add here and then have the brackets indicating there. So along grade 1, what we have is also 3200. So what we need to confirm is whether it's also at the centers of the bases. It looks like it because 3200 here. Let me just see. Okay, apparently this is 1000. So from the 1000, we have, okay, it's at the center of the strip footing. Okay, so center of the strip footing. So at the center of the strip footing, the 600. So we'll take the other half. So it means they are the same. So in that case, I'll take times 4. Okay, because basically they are the same. The one at the top, on the sides, all alike. So multiply that times 4. So once I do that, I have now gotten the total length of the strip footing. Then I will multiply that by the width. And when you do so, the width of it, you normally get the width of it from the section. This is the section of the strip footing, and it gives me 0.6. Okay, so the 0.6, then the depth of the concrete strip footing is 200. Okay, look at this. This is the one I'm talking about. So here is this is the depth, and of course this is the width of the strip footing. So with all that, then I now have, I multiply the total length times the width of it times the depth of 0.2. Okay, so this should give me the volume of the strip footing in that. Okay, so as usual, as we had stated earlier, is that we normally have to round up to the nearest whole number. So that is what I will do. So let me just have that to 0. Okay, so what I'm doing here, I'm just rounding up to the nearest whole. Let me see, 1 2 3 1 2. Yeah, seemingly I need to add another one there. Good. So I have 2 cubic meters for the strip footing, and very quickly I will also get column bases. So in the column bases, it's also measured in cubic meters. That is according to the standard methods of measurements. All right. So the volume of the column bases, I'll just go to my plan. This is the plan. All the column bases are squares of 1000 each. So I'll take 1 times 1, then multiply by the depth of the concrete in the column bases. Okay, so this is the detail of the column base, and it's stating 1000 times 1000 times 350 base. Okay, so the final figure there is 0.35, which is the volume, which is the depth of the column base. Then you multiply by the number of the bases. How many bases do we have? 1, okay, 2, 3, 4. So those are 4 bases. So from the 4 bases, the volume is as that. Okay. Again, I will round this up to the nearest whole. Let me just have 2 brackets here. Okay, so what do I have? That is 0. Okay, I have another 2 cubic meters for the column bases. Then lastly, on this, the item that I wanted us to cover is the foundation slab. Okay, so this is a slab. So slab, you normally have to read the entire description so that you get the thickness and so on. So this is 150. Okay, this is on the detail of the section. We have 150 millimeters thick ground floor slab enhanced with BRC, that is dust reinforcement to it. But of most importance to us today is the thickness. So this is 150 millimeters thick slab. So that is what we have. And this one is measured in square meters. Okay. So the square meters go up to where we have the foundation layout so that we get the area. Okay. And the area of this is basically, you get it at the faces of the external walls. Okay. So this is 3.2. You add half of the wall here, okay, and another half of the wall here, because according to the dimensioning way here, the dimensions have been given from the center of the walls. Okay, and our wall, as per the section, our wall is 200 millimeters thick. Okay, so 200, half of 200 is 100. Okay, so that means I will calculate our length, which is basically the same because it's a square. So this is 3.2. Then I will add 0.1 times 2. Okay, so that gives me the length on one side. Then I multiply that times the same. Okay, so what I mean is I will multiply the other part is also 3.2 plus 0.1 times 2. Okay, that way. So this should give me the area of the floor slab. So I will round this. I will round it up again. Okay, I will round it up. Let me see. Yes, perfect. So I have 12 square meters for the slab. So the next portion, which we are covering next, is now to get material quantities of the items we've mentioned, or we've done them. We've done the quantities in terms of the areas and the scope as we've done. So that brings us to this portion. And now what we do, these particular items, this is basically concrete. And what we've done, we've gotten the scope or the quantities in terms of the dry volume. Okay, so that is why we have strip footing, we have cubic meters, which is 2. Column bases, the same. And then the slab, we also have an area of 12 square meters. Okay, So this brings us to now the constituents of the concrete that we are dealing with here are as follows. Okay, so that is why we are going to break it down. So first of all, we have cement. Okay, then we have sand, and then we have ballast. All right, so the next bit that you also need to take into account is that we talked about class 20 of concrete, and class 20 of concrete is of to a certain mix. Okay, so the mix normally is normally 1 to 2 to 4. Okay, so class 20 of concrete, the mix, let me just note the mix on the side, is 1 to 2. Okay, let me just note it here, 1 to 2 to 4. Okay, so that is the mix, and that means the mixing of cement is 1. Okay, then sand is 2 parts, and then ballast is 4 parts. Okay, so that is the ratio of class 20. The mix is 1 to 2 to 4, and the meaning of each and every one of them is that cement is 1 part of it, of that ratio, and then sand is 2 part of that ratio, and then ballast is 4 as part of that ratio. So moving on, in as much as this is concerned, then the type of batching is now what should be our next question. So in many cases, we do volume batching, okay, because it's the most common one and most convenient in terms of what you'll find on site, what we call volume batching. So we normally batch according to the volume. So this is now where the ratio comes down to, and as you've noted, it's now according to volume. This is now 1, and it's according to a bag, 1 bag of cement. And then the 2 is according to the wheelbarrows. Okay, so 1 bag of cement will go with 2 wheelbarrows, and also will go with 4 wheelbarrows of ballast. Okay, so this should be your first point to note, that it's 1 bag of cement and the bag is 50 kg. Okay, of course wheelbarrows are more or less of standard sizes, so this is what your concern is much going to be next. So once you've known this, then it means you've already broken down this item. But now we now need to know that we have a strip footing of 2 cubic meters, column bases of 2 cubic meters, and slab of 12 square meters. So we all need, because they are all in the same the 3 items or the 3 elements are in different different units. So we need to convert. The next stage is convert all the quantities to 1 unit, okay, or to similar unit. So I will convert all these items into cubic meters. Okay, so the total volume in this case is going to be, I'll take 2, add the other 2, and then this one I now convert it into cubic meters by multiplying by 0.15. So I take the area times 0.15, which is the thickness. So in this case, I am now okay because I now have cubic meters, and it's 5.8. Okay, so as usual, it's let me see, yes, yeah, so I will round this up so that I deal with only whole numbers. So this is what I'll do. So I have 6 cubic meters at the total volume of the elements that I'm dealing with. So then next is from a class 20 of concrete, then you need to know, because now here we are dealing with 3 unknowns. You now need to know how many bags of cement are you supposed to go with for this specific class. And it's as a result of expertise and also research and dealing with such issues on site and the experience that has built with time. I've noticed that we do about 6 bags of cement for every cubic meter of a class 20. Okay, so I have one known one, so I'll go with the cement. Okay, cement 50 kg bags. So on every cubic meter, I've said we deal with the cubic meter, 6 bags of it. So let me just make this better. So total volume in cubic meters is that. Then here I'll talk about ID, then I talk about material. I'll talk about material here, and then I'll talk about each per cubic meter. Okay, so that we know on every cubic meter it's supposed to be this number. So on each cubic meter we are talking about 6 bags. Then I'm going to look at the total bags. Okay, so the total bags would be, I have here 6. I have there 6 bags per cubic meter times the total cubic meters we are dealing with, which is 6. So that means I'll need 36 bags of cement in that case. Then the next item I'm going to look at is sand. Okay, now the sand here we should be talking about tons. Okay, so we are talking about tons, and that leaves us with, now according to the ratio, we come back to the ratio here. The ratio is stating that for every 1 bag of cement we are supposed to consume 2 wheelbarrows of sand. Okay, so that means on every cubic meter, what do we have? So on every cubic meter we should be having this is now 6. Okay, 6, then we multiply by 2. Okay, so what that means, if we have 6 bags of cement on every cubic meter and each and every bag of cement is taking 2 wheelbarrows, then we have 12 wheelbarrows. We have 12 wheelbarrows in every cubic meter of concrete. Okay, and as well as I noted, it's also as a result of research that you note that about 8 wheelbarrows should give you 1 ton. Okay, 8 wheelbarrows should give you 1 ton. So we come to another unit. So this is now in terms of tonnage. So we have around 1.5 tons of sand in every cubic meter. And as you can follow how we've come to that, first we get the total number of wheelbarrows in every cubic meter, which is, take the number of bags of sand times 2 according to the ratio, and then you divide by 8 to get the number of tons, because 8 wheelbarrows should give you 1 ton. So this tells us that we have around 1.5 tons of sand in every cubic meter. Then you multiply that times 6, which is the total cubic meters that we have for our elements that we're dealing with. So this gives us 9 tons. Okay, this gives us 9 tons of sand. Then finally we talk about the ballast. Okay, ballast as well we talk about tons. Okay, so the same way we dealt with sand. So for the ballast, every bag of cement, okay, every bag of cement will take 4 wheelbarrows of ballast. Okay, so what that means is that now we have a total of 6. Therefore, we should be taking the 6 multiply by 4. Okay, because every bag goes with 4. So it's the number of total bags, which is 6, times 4. Let's see, that gives us 24 wheelbarrows of ballast. So out of this, we simply divide it by 12, because now, as opposed to sand, where 8 wheelbarrows was giving us a ton, now about 12 wheelbarrows should give us a ton for the ballast. Okay, so this means we have about 2 tons of ballast in each and every cubic meter of concrete. So we'll take again the 2 multiply by 6, which is the total volume. You get 12 tons. So basically that is the process, and as up to now, that is now how you go about calculation of your materials for concrete in that manner. Okay, so for those who have always been interested in building upright, this is how you go about it. Okay, this is how you go about that. So looking at that, from what we've built, you've noted how we come to the quantities of the materials. So for those who have always been interested in how to now build up a rate for maybe a given class of concrete and so on, once you have the quantities of these materials, then now you can multiply by the prices according to what is available within your locality. Okay, so for instance, a bag of cement takes 700 shillings, a ton of sand take around 1600, ballast around 1600. Then you multiply by the quantities of each of those items for every cubic meter. Then you get this breakdown. Once you've done that, then you estimate for labor. Labor per cubic meter, say 3,500 shillings, okay? Kenya shillings, that is. So when you add all these items, then you're supposed to get the unit rate of concrete, okay, per cubic meter. So this is how it goes. And of course, you don't forget to add some overheads and profit, okay? Some overheads and profit here. Okay, so say 700 shillings for every cubic meter. Then you add that, you get around 14,000 as a unit rate for concrete. Okay. Well, so that brings us to the end of our session, and I really hope that it was worthwhile. You watched and you understood quite a number of items as it was meant to be. If you find these videos helpful, please subscribe so that I can be able to reach more number of people. For any support that you do wish to have for the channel, you can join the various categories that we have for membership, so that you can get these items free of charge, in terms of the templates, in terms of short consultations in matters of building rates and so on. So that is where we come to a close of our session. Take care till we meet again in our next session. Bye bye.